Hello everyone. In the previous video, we have seen what is Node Port Kubernetes service and how we can access the applications deployed in the Kubernetes cluster using the Node Port service. And we have also seen what are the disadvantages that we get when we use the Node Port service. So today in this video, we'll see what is a load balancer Kubernetes service and how we can access the applications deployed in the Kubernetes cluster using the load balancer. And we'll also see how this load balancer Kubernetes service will overcome the disadvantages that we face while using the Node Port service. So let's get started. So this diagram looks similar to the one which we discussed while talking about the Node Port Kubernetes service. So the only difference that you can observe here is the load balancer service. So for creating the load balancer in Kubernetes, you can create a manifest file and you can apply that manifest file for creating the load balancer. So in that manifest file, you can also specify the port on which you want to access the application. For example, if you want to access the application on port 8080, then you can specify that port in the load balancer manifest file so that you can access the application on that port from the browser. And when you create that manifest file and apply, so there will be a load balancer created along with the node port service as well. And this will expose a random port which ranges from 30,000 to 32,767 on both the nodes. So if you remember, while we are talking about the node port service, we have to access the application using the node IP address as well as the node port. But when it comes to the load balancer, when you create a load balancer, there will be a static IP address that would be assigned to the load balancer, and you can use that load balancer IP address along with the port that you specify in the manifest file to access the application. So here, if you observe, we are not exposing any of the IP addresses of the nodes to the consumers or the other teams to access the application. So we are directly exposing the load balancer IP. And one more thing is we are specifying our custom port in the manifest file. So we are not using a 5-digit port for accessing the application. Here you can specify, for example, 443 or 80, and you can use those ports for accessing the application. And moreover, this load balancer IP will not change. So that would be dynamic, and there is no need for you to change the URLs very frequently. Or when it comes to node port service, whenever the node IP address changes, you have to change the URL for accessing the application. But in case of load balancer, this IP will not change. So one more thing that I want to mention here is this load balancer Kubernetes service is supported when you create your Kubernetes cluster on cloud platforms such as GCP, AWS, Azure, etc. But if you create your Kubernetes cluster on on-prem servers, so this Kubernetes load balancer service might not be supported. So please be aware of this one and cross-check while you create this load balancer service. So let's move on to the demo part and see how we can create this load balancer and how we can access the application using the load balancer Kubernetes service. So using the Azure Cloud Shell, I have already authenticated to the Azure Kubernetes cluster. So let me show you the files that are there in the current directory. So you can see the pod.yaml as well as the lb.yaml. So let me open the pod.yaml first. So this is the manifest file that we have already created in the previous video. If you haven't watched that video, please watch that video. So here, basically, we are creating a pod that is the Nginx pod in dev-ns namespace. And here you can see we are giving app Nginx-app the label for this pod. And if you see here under the ports, the container ports we have specified as 80. So that means this application will be up and running on port 80. So let me go back and let me run kubectl apply -f pod.yaml. So this will create the pod in dev-ns namespace. So you can see the pod is created. Now let me open the lb.yaml file, and here you can see this is the manifest file for creating the load balancer. So the kind is the service, and here you can see the type as load balancer. Since we are going to create the Kubernetes service as of type load balancer, so we are providing the type as load balancer, and we are creating in the same namespace where we have created the pod in the dev-ns namespace. And here you can see we are specifying the same label that we have used in the pod manifest file. So make sure you provide the same label in the service under the selector as well. So here you can see the port that we have specified as 8080. So that means we can access the application using the load balancer URL and the port 8080. So once you access the load balancer URL along with the port 8080, so that traffic will be routed to the underlying pod, so which will accept the traffic on port 80. So the container will be running on port 80, but you can access the application using the load balancer URL on port 8080. So let me save this file and let me run kubectl apply -f load balancer dot yaml. So this will create a load balancer in dev-ns namespace. So here you can see the service nginx-lb has been created. So let me get all the services kubectl get svc that are running in dev-ns namespace. So here you can see there is one service that is running of type load balancer. So you can see the cluster IP is created, and along with that a node port 30,894 which will be exposed on all the Kubernetes nodes. So here you can see there is one external IP address. So this is the public IP address that is attached to the load balancer. So using this IP address on port 8080, so you can access the application that is mapped to this service. So let me copy this one and go on to the new tab and paste this one along with the port 8080. And if you click on enter, so you can see we are getting the response from the application pod that we have deployed. So Nginx is the application that we have deployed, so you are getting the response from that pod. So in this way you can deploy the load balancer on top of pods, and using the static IP address you can access the applications that are mapped to this service. So the disadvantage that we get while using this load balancer in cloud is this load balancer is very costly. Let's say if you have 10 applications deployed in your Kubernetes cluster, and if you want to access all those applications using the load balancer, you have to create 10 load balancers, right? So one for each applications. So that would increase the cloud cost. So in the next video, we'll see what is ingress and how does ingress help overcome this disadvantage of using multiple load balancers in order to access multiple applications. So if you haven't subscribed my channel, please subscribe to this channel so that you will get more updates on my next videos. Thank you.